Okay, welcome to chapter 6.3. We're on page 392, and they're presenting a scenario to you, and we're going to solve that scenario using linear combinations. Now, if you read, they give you a scenario, and what they say is Constance owns a lunch cart. She changes her menu daily. Yesterday, she offered chef salad for $5.75 or a hoagie sandwich for $5. She sold 85 lunches and she totaled $464. Figure out how many chef salads and how many hoagies she sold. Now, the easy way to do this would be to ask her. However, we're going to do things the hard way. So what we're going to do is we're going to figure, okay, we know that she sold so many chef salads and so many hoagies, and the number that she sold was 85. We also know that if you take the chef salad that she sold and multiply it times $5.75, that'll give you the total money she took in from chef salad, because each one cost $5.75. We also know that she sold the hoagies for $5 each, so 5 times something gives you the total of what she took in from selling sandwiches. We also know that her grand total was $464. And then they are going to ask you to create a equation for the first situation, the total number, and then they're going to ask you to create an equation for the second, if you walk through the problem, the $464. So I've already done that for you, okay? Then they're going to ask you, how could you solve this? There's different ways we could do it. We could graph both these, look for the intersection point, and that intersection point would be the number x and y for each one. We can also do it through linear combination, which is what we're going to do here. So here's what I'm going to do. I have this set, and I'd like to isolate the y or the x. So here's what I can do. I'm looking at this 5y, and I'm thinking if I could add negative 5y to that, it would be gone. I can do that. Here's how. If I multiply each one of these times negative 5, notice how the negative 5y, if I combine this, if I add them together, the negative 5y and the 5y will wipe each other out, leaving us just with an x. Is that okay to do? Absolutely. The only rule is you have to do it to every part. You can't just do it to the negative 5y and say I'm done. You have to do it to all the parts. Okay? So I did it over here, and now I have it set nicely. Negative 5x minus 5y equals, remember we had to multiply that, negative 425. And when I do that, look what happens. That negative positive 5y, they're gone. Here, I'm basically taking 5.75, I'm subtracting 5x, that's going to leave me 0.75x. This got wiped out, which is what we want. And here, I'm going to wind up with 39. So what that tells me is 0.75x is equal to 39. If I take 0.75 and divide it into 39, you come up with 52. So what that means is that she sold 52 chef salads. Rest of the part's pretty easy. We now know that, think about it, let's go back to the original equation, which was x plus y is equal to 85. She sold a total of 85 salads and sandwiches. We now know that she sold 52 sandwiches. So I have 52 plus y equals 85. We subtract 52 from both sides. That's going to leave me with y is equal to 33. In other words, she sold 33 sandwiches. Now, if you want to check and see if this is correct, all you have to do is just multiply 52 times 575, multiply 5 times 33, add it together, and you'll discover that yes, it does equal $464. So if you're doubting yourself, go back into the equation. This second equation, right here, we would insert 52. Here we would insert 33. and see if it works. If it does, you know for sure you have the right answer. All right, so you're off to the next page. I think you'll find this helpful as you're working on page 393.